Imagine writing a set of instructions so clear, so elegantly automated, that another expert in your field looks at it and says, this is terrible. I can't read this at all.
Right, yeah, it sounds totally backwards, but that is the paradox we're diving into today.
Exactly. So welcome to the deep dive, because if you've ever found yourself caught between spelling out every single detail for someone or just trusting a slick automated system to do the work, you're going to find this really fascinating.
Yeah, it's a debate that comes up everywhere, really.
It does. And today we're looking at a specific snippet from a developer's field notes. Author is named Ang, and the source we're analyzing is titled Notes-on-Haskell-Programming Part 194, Replacing Boilerplate Pattern Matching with Traverse.
I know, the title sounds highly technical,
Yeah.
but the core conflict that Ang is documenting here is incredibly universal.
Oh, for sure.
We're basically exploring the tension between explicit, repetitive instructions, what programmers call boilerplate, and elegant abstractions.
Right, the stuff that cleans it all up.
Exactly. We actually get to look over Ang's shoulder and watch a few lines of code transform step by step. And it reveals this massive debate about what makes communication, and specifically code, actually readable.
Yeah, I like to think of it like the eternal struggle of organization. You can build a system where every single detail is meticulously cataloged right out in the open, or you can build a minimalist system where all those messy details are hidden away in drawers.
That's a great way to put it.
And we are going to look at why someone might fiercely defend that messy, out in the open system. So let's start with the before picture in Ang's notes, just to understand why this code was bothering the author in the first place.
Okay, so the starting point for Ang's code relies on a structure that begins with the phrase case result of.
Case result of. Got it.
Yeah. And to understand what that does, we need to know what a result actually looks like in this specific environment.
Right.
A result here generally has two possible outcomes. The first outcome is called a left error, with error simply being shorthand for error.
Okay, so meaning whatever the program was trying to do, it just failed.
Exactly. Say downloading a file or reading a database, it hit a wall.
The system tried to do the job, failed, and generated an error message.
Correct. Now, the other possible outcome is called write bytes. This means the operation was a complete success, and we actually got our data back.
Write bytes.
Yeah, and there's actually a brilliant little piece of programmer wordplay embedded right here. By convention in this language, the successful data is placed on the right because it is the right outcome. It worked.
Oh, I love that.
Yeah, it's clever. And that leaves the left designated for the errors.
I love when technical systems sneak in a little pun like that. So basically, every time this specific piece of the program runs, a package gets delivered.
Right.
And that package is either a left error, which is a broken package, or a write bytes, which is a good package containing the data we actually want to use.
Nailed it.
Yeah.
And that brings us to what the case result of statement actually does. It acts as a set of manual, explicit instructions for how to handle those two types of packages.
Okay.
Ang points out that dealing with the left error branch in this manual way forces the developer to write redundant boilerplate code.
And boilerplate, that's a term that gets thrown around a lot.
It does, yeah.
Right.
But in programming, it specifically refers to sections of code that you are forced to include in multiple places with little or no alteration.
So it's structurally required.
Exactly. It's required by the language to make the program function, but it doesn't add any unique logic to your specific goal.
It's like the bureaucratic red tape of coding.
That is exactly what it is.
I want to visualize this case result of structure to really understand the pain point Ang is feeling here. Imagine you're standing in a manual mail sorting room at a post office.
Okay, a manual sorting room.
Yeah. Every single time a package comes down the line, you, the worker, have to physically stop the belt, pick up the package, and look at the label.
Right, you have to do it by hand.
Exactly. You have to ask yourself a series of questions like, is this package broken? Yes. Okay, well, let me walk this over to the error bin. Is this package good? Yes. Okay, let me place it on the processing table.
And you have to perform that exact sequence for every single package.
Every single one.
When you translate that to code, you are writing out those exact structural steps over and over again throughout your program. You're telling the computer how to sort the mail, rather than doing the actual work of processing the good mail.
And if I'm coming in to read your code later, I have to read you doing that sorting every single time.
Yep.
Like, pick up package, check if broken, walk to bin. It sounds exhausting to read, which is obviously why Ang wanted to change it.
And nobody wants to read that over and over.
Yes. But here's what I want to push back on the whole premise, because Aang makes a really fascinating note right at the start of the journal entry.
Oh, about Golang.
Yes. The text mentions that some developers, specifically those accustomed to a programming language called Golang, might argue that removing this boilerplate actually reduces readability.
They do, yeah.
Why on earth would someone prefer the manual, tedious mail sorting method?
Well, that gets to the philosophy of visibility in software engineering. In certain programming cultures like Golang, developers value explicitness above almost everything else.
So they want to see it.
They want to see it all. They actually want to see the error handling right in front of them, even if it is highly repetitive boilerplate.
I mean, think about the last time you handed off a critical project to someone else. Did you spell out every single step? Because you needed to know exactly how they were going to handle things if something went wrong.
Right, exactly.
Or did you just give them the final goal and trust them? It sounds like Golang developers want to spell out every step.
They do, because there are no surprises when you spell it out. Imagine you're debugging a complex, massive software system at like 2 in the morning.
Oh man, sounds stressful.
It is. The servers are crashing, and you need to find out why. A Golang developer wants to read the code and see exactly, mechanically, how every single error is handled.
They want to see the worker picking up the package, looking at the label, and walking it to the bin.
Yes, because if that process is hidden away by some automated robot, they feel a terrifying loss of control. The manual sorting room might be tedious to write, sure, but to them, it's incredibly easy to read and understand because absolutely nothing is happening behind the scenes.
Wow, okay. It reminds me of the difference between driving a manual transmission car versus an automatic.
Oh, that's a good analogy.
Right, because the automatic is undeniably easier for your daily commute. But the manual driver knows exactly what gear the car is in at every given second because they physically put the car in that gear themselves.
Yeah, they have total mechanical sympathy with the machine.
Exactly. So how does Aang address this?
Well, Aang completely acknowledges that perspective in the text. But we are in a Haskell programming context here, which is a language known for heavy mathematical abstraction. In this context, Aang decides the boilerplate is simply too heavy. The manual sorting is creating visual noise that obscures the real logic of what the program is actually trying to accomplish.
So the red tape is getting in the way of the actual work.
Exactly. So to clear that noise, Aang moves to the first refactoring.
Okay, so we are firing the manual mail sorter.
We are.
Let's look at what Aang brings in to replace them. What's the new code?
The source text shows Aang replacing the entire manual case block with a much shorter line of code. Traverse, and then in parentheses a backslash, bytes, an arrow, and a do statement.
Okay, wait, let's break down how this traverse mechanism actually functions, because jumping from the manual mailroom straight into that syntax feels like a huge leap.
It is a bit of a jump, yeah. So when you call traverse and feed it a function and a result, it takes over the sorting for you. But it possesses a very specific behavioral superpower.
A superpower. Okay, I'm listening.
If the result it receives is a left error, or broken package, it immediately performs an action called short circuit.
It just stops everything.
It's essentially yes. The code in Aang's notes shows that when traverse encounters an error, it returns pure and a left error in parentheses without ever attempting to run the rest of your instructions.
Wait, what does pure mean in this context?
Good question. Pure is basically a command used to take a raw value, like our error, and package it back up in a standardized way so the broader system knows how to handle it.
Oh, okay.
Yeah. It sees the broken package, puts it in a standard reject box, and passes it straight up the chain, completely stopping the current operation.
So when Aang writes the word traverse here, they are literally installing a smart conveyor belt in our factory.
Exactly.
The belt has like a built-in barcode scanner. If
Yeah.
that scanner reads an error barcode on a package, an automated arm instantly hits it off the main belt and into the reject bin. That is the short circuiting.
Yep, the package never even makes it to the processing station.
It bypasses it entirely.
Which means, as the person writing the instructions for this factory, you only ever have to write instructions for what to do with the good packages. The right bytes.
Because I don't have to write out the error handling. I trust the belt is already managing the garbage.
Exactly. You are describing what the industry calls the happy path. And that really highlights the incredible beauty of this approach.
It does seem really clean.
Right. By trusting Traverse to handle the left error automatically, the bureaucratic boilerplate vanishes from your screen.
Wow.
When another developer reads your code now, they aren't distracted by the red tape of error routing. The code focuses entirely on what happens when things go right. The cognitive load on the reader is drastically reduced because the core intention of the code is placed front and center.
I can definitely see the appeal. I mean, it feels so much cleaner to just write out the happy path.
Yeah, it's very elegant.
But Ang doesn't stop with traverse, right? The code is shorter, the bulky case statement is gone, but the notes point out another area for improvement.
Yes, there's one more step.
Because we still have this ugly, nameless set of instructions sitting directly on the conveyor belt. And this brings us to the final polish, dealing with the anonymous function.
Right, so in that first refactoring step, the new code looked like this. Traverse, backslash, bytes, arrow, do. That middle section, the backslash, bytes, arrow, do part, is an anonymous function.
Anonymous function, meaning it doesn't have a name.
Exactly. The little arrow symbol in there is essentially the start of our happy path instructions for the good packages. It's a block of logic that performs a specific job, but it doesn't have a formal name attached to it.
So it's just floating there.
Yeah, it's just written out in line right in the middle of the main operation.
Okay, to stick with our factory, it's like having a messy, handwritten sticky note slapped onto the side of the processing station with a list of tasks on it, rather than having an official titled manual in the filing cabinet.
That's a perfect way to visualize it. And Ang decides to formalize that sticky note.
Okay, how?
The final transformation in the field notes changes the code to a remarkably clean line. It becomes traverse, parentheses, write output, outpath, close parentheses, result.
Oh, wow. So we took the anonymous sticky note and gave it an official title, write output.
Exactly.
Yeah.
Ang's notes provide the exact definition of this newly minted write output function, and it requires two specific ingredients to work.
What does it need?
It takes a file path, labeled outpath, and it takes our successful data, which is a byte string labeled bytes.
A byte string.
Yeah, a byte string is just a very efficient way of handling raw chunks of digital data in this language.
So it knows the exact destination where the data needs to go, and it knows exactly what data it is carrying.
Precisely. And inside this new write output function, Ang details three specific steps.
Okay, lay them out for me.
First, it checks to see if the required directory actually exists on the computer.
Mm.
If it's missing, it creates it. The syntax for that is create directory missing true.
Which is just smart plumbing, making sure the physical folder is there before you try to shove a file into it.
Exactly.
Yeah.
Step 2, it actually writes the data to the disk. The code uses BL write file outpath bytes.
BL write file.
Yeah, with BL write file being the specific tool in this language used to take that raw chunk of data and permanently save it to the provided path.
Got it. And the third step.
Finally, step 3. It returns the path it just wrote to, signaling that the job is complete. The syntax there is pure outpath, once again using that pure command to package that success message back up for the system.
Okay, let me make sure I'm following. We took those three distinct mechanical actions, check the folder, write the file to the disk, confirm the path, and we bundled them up into a single named function called write output.
Yep, you got it.
And then we took that bundle and plugged it back into our smart conveyor belt. So now the final code just reads traverse, write output, outpath, result.
Right. And by giving those steps a name, Ang shifts the code from imperative programming to declarative programming.
Imperative versus declarative. What's the difference?
Imperative programming is telling the computer how to do something. Check the directory, then write the file, then return the path.
Step by step.
Exactly. Declarative programming, on the other hand, is simply telling the computer what you want to achieve. Just traverse this result and write the output.
Okay, I understand the mechanism, but this is exactly where I start to feel that Golang developers' frustration creeping back in.
Really? Why is that?
Well, we are talking about readability, right? But by pulling those three steps out, the directory checking, the disk writing, the confirming, and just slapping a label on them, aren't we actively hiding the real work from the person reading the main code?
Ah, you are hitting on the absolute crux of the readability debate in software design.
Because if I am reading the main flow of this program, all my eyes see is write output. I don't see that it is secretly checking for missing directories behind the scenes.
True.
I don't see the specific tool it is using to write to the disk. I feel like I'm reading the back cover summary of a book instead of reading the actual book itself. Why is this considered better by anyone?
Well, it all comes down to trust. This declarative style requires a massive leap of trust in abstractions.
Trusting the machine.
Yeah. And trusting the other developer. To someone who embraces that mindset, reading that line, traverse, write output, outpath, result, is a beautiful experience. It reads almost like a plain English sentence.
I guess it does, yeah.
It communicates the ultimate intent of the architect perfectly without cluttering up your screen with the mechanical how.
So it tells me the what, not the how.
Exactly. But as you pointed out, the danger is that it requires you to trust that the underlying named function, write output, does exactly what its name implies, and only what its name implies.
Right. Because what if it doesn't?
Exactly. If you run into a poorly named function, say a function called write output that secretly also deletes old files or sends an email notification, you would have absolutely no idea just by reading the main line of code.
That sounds like a nightmare.
It is. You would have to stop what you were doing, hunt down the definition of write output in a completely different file, and read the mechanics anyway.
See, if I am a developer who has been burned by poorly named functions in the past, I am going to hate this declarative style.
Yep. You'd want the imperative style.
Yeah, I want to see the sticky note. I want to see the anonymous function written out right there on the conveyor belt so I know exactly what the machine is doing to my data. I don't want to trust the abstraction. I want to verify the mechanics.
And that tension is exactly what Ang is navigating in these notes. You are basically trading explicit mechanical visibility for higher-level conceptual clarity.
It's a trade-off.
A huge one. The Golang mindset says, show me the mechanics. I don't mind the visual clutter if it means I understand the machine. The Haskell mindset, at least in the context of this specific refactoring, says, hide the plumbing, let me read the architect's intent so I can understand the big picture.
It is such a fascinating trade-off, especially when you step back and look at the journey of this single piece of code. I mean, it's been quite a ride for just a few lines of text.
It really has. When you look closely at the text, the evolution is striking.
We started with a clunky manual case statement. We had our poor mailroom worker checking every single package for errors, writing out the same boilerplate code over and over again.
Lots of red tape.
Right. Then we upgraded the factory. We brought in the smart sorting conveyor belt called Traverse. This allowed us to short-circuit the errors entirely, automatically tossing the broken packages into the reject bin so we could focus purely on the happy path.
Which was a massive improvement.
But we were still using an anonymous function, a messy sticky note on the belt.
Which led to the final step.
The final polish. We took that messy anonymous function, those raw imperative instructions, and we tucked all those details away into a clean declarative named function called write output.
Yeah, we moved from manual sorting to a plain English sentence.
Ang's short journal entry perfectly encapsulates the daily, almost microscopic decisions programmers make every single time they sit at a keyboard.
They really are constantly weighing these trade-offs. They're balancing the removal of boilerplate against the highly subjective nature of readability.
There's no right answer, is there?
No, there really is no mathematically perfect answer. Code is ultimately written for machines to execute, but it is written for humans to read, understand, and maintain.
And humans, no matter how technical, are notoriously subjective.
Extremely. What is incredibly obvious to one developer is an opaque, terrifying mystery to another, simply based on the paradigms and languages they're used to working in.
Which leaves us with a pretty compelling thought to mull over as we wrap up today's deep dive. The author specifically noted that this cleaner, shorter code might actually be less readable to someone from a different programming culture.
Yeah, it really challenges a core assumption.
It begs a much larger question that extends far beyond just writing code. Is simplicity in any kind of writing or communication actually an objective standard?
That's a great question.
Because we always strive to make things simpler, cleaner, shorter, right? We edit our emails, we condense our presentations, but is that always better?
Right. Who are we making it simpler for?
Exactly.
Right.
Or is readability entirely dependent on the culture, the background, and the expectations of the person on the receiving end? Because if you are used to the manual sorting room, the highly efficient automated conveyor belt might just look like a black box you cannot trust.
It really makes you wonder how much of what we consider clean communication is just us enforcing our own stylistic preferences on someone else's reading experience. Sometimes people just need to see the work to trust the result.
Well said. So as you go about your day, whether you are drafting a quick email, putting together a slide deck, or handing off a project to a colleague, keep questioning the boilerplate in your own life and work.
Definitely.
Ask yourself who you are writing for. Do they need to see all the messy mechanical details to feel comfortable and trust you? Or do they just want the elegant, high-level abstraction?
Finding that balance is the real art of communication.
It truly is. Thanks for joining us on this exploration of the micro-decisions that shape the digital world we all live in. Keep asking questions, and we will catch you on the next Deep Dive.